Somewhere off the coast of Osaka, engineers once agreed to build a runway on ground they knew would not hold still. The seafloor sat 18 meters underwater, and beneath that lay 20 meters of soft clay, so saturated it held 70% water by volume. That is the foundation they chose for an international airport, not because it was solid, but because every solid option had already been ruled out. By the 1960s, the Kansai region was losing ground to Tokyo, economically and culturally, and local planners wanted an airport that could restore its standing. The obvious site, Osaka's Itami Airport, was boxed in by mountains and by neighborhoods that had filed noise complaints for years. It could not expand, and it could not run at night. Planners had also watched what happened at Narita, where seizing rural land for a new runway triggered years of protest. So Kansai's planners decided deliberately to build somewhere no one lived, open water. Kobe was floated as a location first, and Kobe said no. The site moved south, into Osaka Bay, onto water deep enough and empty enough that the airport could finally run 24 hours a day. That freedom came with a structural bill. The bay sat in an active seismic zone, exposed to typhoons capable of pushing storm surges 3 meters high. And under the water they'd chosen, there was no bedrock to build on, only that deep layer of soft Holocene clay, the kind of ground that compresses and shifts for years under any real load. An artificial island 4 kilometers long and 2.5 kilometers wide was the target. Nothing like it had been placed on ground like this before. The first real move wasn't pouring fill. It was trying to fix the clay itself. Engineers drove roughly 1 million sand drains down into the seabed, vertical channels meant to pull water out of the clay and let it compact before anything heavy sat on top of it. At the same time, crews built a containment wall around the site, finished in 1989, made of quarried rock reinforced with 48,000 concrete tetrapods to absorb wave energy. 3 mountains were excavated for the project, yielding 21 million cubic meters of rock and earth. That was the opening move. Prepare the ground and contain the water before committing the fill. The turning point wasn't a single decision so much as a sequence. Rather than fighting the clay's tendency to settle, engineers built to accommodate it. The seawall went in first, sealing off the footprint. Only then did the fill go in behind it, layer by layer, allowing the sand drains underneath to keep doing their slow work of squeezing water out and letting the clay consolidate under a known controlled load rather than an unpredictable one. Mechanically, this is what made the island possible at all. 180 million cubic meters of material went into building the first island, placed as a 30 to 40 meter layer of earth over the seafloor and inside the seawall. 10,000 workers, using 80 ships, logged roughly 10 million man-hours over 3 years to get it done. It was not fast, and it was not simple, but it followed a logic. Stabilize the seabed first, contain the site second, then load it gradually enough that the ground could settle in a way engineers had already planned for, rather than one that would crack a runway later. In 1990, a 3.75-kilometer bridge connected the finished island to the mainland. Construction had started in 1987. The airport opened on September 4, 1994. What the airport delivered was genuinely large. Terminal 1, designed by Renzo Piano, stretched to 1.7 kilometers, the longest airport terminal in the world. The first island covered about 510 hectares. A second island, added later, covers roughly 545 hectares, bringing the total footprint past 1,000 hectares. A second runway, 4,000 meters by 60 meters, opened in August 2007, meaning the project didn't stop at the original island, it expanded onto new ground, built the same hard way. Here's where the documented record runs thin, and it matters to say so plainly rather than fill the gap. The available material does not give a specific subsidence figure, a year-by-year sinking rate, or a confirmed total project cost. Those numbers exist in public discussion of Kansai, but without a verified source in front of us, stating an exact figure would be guessing dressed up as fact. What is documented is the mechanism, the sand drains, the staged loading, the second island, the second runway, all of it consistent with a project that anticipated ground movement and kept building around it rather than treating it as solved once and finished. Whether later settlement matched the original engineering assumptions or forced further correction isn't something this record confirms. That uncertainty is worth holding on to rather than resolving with invented numbers. What isn't in question is how the airport operates now. In 2025, it handled 34.1 million passengers, including 27.5 million on international routes, along with 786,214 tons of freight. Fiscal year 2025 set a record for international passengers, 27.08 million, and a record 142,753 international flight movements. It serves as an international hub for all Nippon Airways, Japan Airlines, and Nippon Cargo Airlines, and as the hub for Peach, Japan's first international low-cost carrier. FedEx built its North Pacific hub there in 2014, using Fifth Freedom rights granted under a 1998 agreement between the United States and Japan. In 2020, Skytrax ranked it the 10th best airport in the world and gave it awards for staff and for baggage handling. So the answer to the question the title asks sits at a specific level of certainty. It is documented, not disputed, that Kansai was built on ground engineers knew was unstable and that they treated that instability as a design input from the very first sand drain rather than an obstacle to eliminate. It is documented that the airport expanded twice onto more of that same engineered ground. What isn't documented here, and shouldn't be stated as if it were, is the precise scale of ongoing settlement or the final price tag people still argue about online. The honest version of this story is that Kansai proves an airport can be built on ground that never fully stops moving, as long as the people building it stop expecting the ground to behave and start engineering for the ground it actually has. That distinction, building for the site instead of against it, is the same question waiting at the next site being reclaimed from open water right now. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.